Okay. One thing which people always say when they do, when we do matrices is, what is the point of them? What's the point of matrices? Okay. Well, I've put an example of where matrices are really useful on the screen here. Okay. What if I wanted to look at this? So here I've drawn a network. Okay. And I've got nodes, so A, B, C, D, and E are those little circles. They're nodes. Okay. And then I've got edges connecting those nodes together. Okay. So you can see, for example, that A is connected to D, and I've also put arrows on these edges to show the direction of the connection. So A would be connected to D, but D would not be connected to A because the arrow is pointing in that direction. Does that make sense? Yeah? Whereas there's some nodes, for example, E and D, where that connection works both ways. Okay? So think of this as you like. If you're actually within this network and you're sitting at A, you can go to D, but you can't go back the other way. Okay, you have to find another route around this network. Now, this is quite an abstract concept, okay? But this could, for example, represent social media. So let's say, for example, you had 5 people in a group, okay? And you wanted to understand the direction of an interaction, okay? So, for example, Xiaoting, let's suppose that you connected with Barbara by sending her a message. But Barbara doesn't like you and didn't send a message back. Therefore, there would be a connection from you to her, but it wouldn't go back the other way. Does that make sense? Okay. But you can also look at this, for example, with Google. Okay. This is literally how Google works. It works on the idea of a page rank algorithm. So it says if one page is linked to another page, but that link is not reciprocated, then it would represent a network or connection like that. Okay. So networking analysis is a really, really useful concept. But the thing is, you can imagine if it looks quite busy, like this diagram looks quite busy. If it looks quite busy with 5 nodes, so 5 things in it, can you imagine what it would look like with hundreds upon thousands upon millions of nodes in the network? It gets really busy. And then you say, well, how on earth do I try and understand what's happening with this network? The answer is using matrices, okay? So what I'm going to try and do is build a matrix from this network to show you how it works, okay? So I'm literally just going to write A, B, C, D, E, okay? And then A, B, C, D, E. And this is going to be a very, very simple adjacency network. So adjacency just means next to. If there's a connection, I'm going to put a 1. If there's not a connection, I'm going to put 0. That's it. Okay? So is A connected to itself?
Yes.
Yeah, look, A is connected to itself. There's a connection which will get you back to A. So I'm going to put a 1 there. Is A connected to B? Yeah, A is definitely connected to B. Is A connected to C? Yeah, there's a connection there. Is A connected to D?
Yeah. Yes.
Is A connected to E?
No.
No, there's no direct connection which gets you from A to E. Is that okay? Okay, let's do the same for B. Does B get connected to A?
No.
No, because look at the direction. It's a directed network, okay? Is B connected to B?
No.
No. Is B connected to C?
Yes.
Yeah. Is B connected to D?
No.
And is B connected to E?
No.
Okay, what about C then? Is C connected to A?
Yes.
Yes, absolutely. Is C connected to B?
No.
No. Is C connected to C?
Yes.
Yeah. Is C connected to D?
Yes.
Yeah. Is C connected to E?
No.
No. Okay. What about D then? So is D connected to A?
No.
No, because the directions go in the opposite direction. Is D connected to B?
No.
Is D connected to C?
Yes.
Is D connected to D?
No.
And what about is D connected to E?
Yes.
Okay. Is E connected to A?
No.
Is E connected to B?
No.
Is E connected to C?
No.
Is E connected to D?
No. Yes. Deconnected.
E is connected to D, but it's not connected to itself. Okay? So in other words, if I strip away all the context here, I just put that on to help you. If I strip away all of this context, what I'm left with is something called an adjacency network, or an adjacency matrix for this network. And now I can start to look at this and say, okay, what is the most influential node? In other words, which node has the most connections to other nodes? Can you see that it's probably going to be A? Because that's got the most connections to it. All of the other ones, like this has got 4 connections, okay? This one's only got 1 connection to another node. This has got 3 connections, this has got 2 connections, and this one's only got 1 connection. Okay, so I can start to say, just simply looking at the adjacency matrix, and I can do sort of more complicated matrix algebra on this, okay? It's just an overview, that I can probably say A is the most influential node in this network. So if I was Google, And if these were representing web pages, I'd be like, I'm going to put A at the top of my search results. Does that make sense? Okay.
Yeah.
Now, like I say, I've not really shown you many matrix tricks which you can do with this. There are loads which you can do with it. But just purely from thinking about networks and matrices as two things, you can start to do some quite interesting thing with these matrices. They're really useful in everyday life. Is that okay?
Yes.
Good, fantastic. Let's take a 10-minute break.